Hi everybody, welcome to the 7th International Conference of Recent Trend in Computer Science and Electronic, January 5th to 7th, 2022, room 105, University of Hawaii, Manoa campus. Today we're going to talk radio spectrum transformation model and small cells for the deployment of 5G networks. The authors are Petrlik, Santos, Sotelo, Jorge Mayhuasca, Roberto Esparza, and Bermejo. We are from Lima, Peru. Abstract. The development of research work focused in technology 5G networks. During the study process, it was possible to process and analyze data related to radio frequency spectrum, small cell systems, and technical aspects of make up the 5G infrastructure. Therefore, a wide and sufficiently viability of deployment 5G network technology is determined. In the period between 2020 and 2030, consider the improvement of service not only in terms of speed and or performance, but also aspects as well as MBBB renewed mobile bandwidth with coverage 10 times faster in rural areas, MTC, communication mass between devices, a large number of linked mobile devices and their Internet of Things IoT environment in a massive way, URLC, viable communication with ultra-low latency, response times when receiving and sending messages of data lower latency greater response time. This communication behavior consists of 5G networks to create an impact on human society from the systematization and automation of intelligent industries, autonomous vehicles, remote telemedicine acquisition in real time. Likewise, warranty in the implementation of the technology by acquiring a radioelectric spectrum, a limited intangible natural research through the various signals called electromagnetic waves to circulate which from telecommunications services based on the frequency band from the deployment of 5G networks with a low band of 700 MHz, a middle band of 3600 MHz as a core of 5G technology, and a high band of 25 GHz. According to the mobile communication market, the 3600 MHz bands is considered potentially more beneficial than 700 MHz than 25 GHz. In relationship to small cell sufficiency, characteristics and capabilities are established in the 5G network technology design and build, which makes it possible to identify one of the most appropriate small cell structures. And obviously, it is possible to identify that between the wavelength to mean dipole and mean asymmetric dipole wavelength, the bandwidth is limited to despite having applied optimization techniques in the structure, while the average asymmetric dipole wavelength was managed to experience increase in bandwidth that allows increasing the line width, and this in consequence has a light size of structure. Relative both small cells deploys have spherical degrees of release in during the increase of impedance bandwidth. Keywords: radio frequency bound, small cells deployment, and 5G. Introduction. The communication system through the mobile device was developed rapidly in the last decades, providing exponential evolution to the mobile telephone. From the first generation of 1G, based on analog and rigorous system designed for the voice transmission, consequently was a direct to improve the quality to our 2G technology. Here we can see the advance of how it works from 1G to 5G. We also see some aspects of IoT, and many frequencies were located, and we see now the spread of the 5G system are located in 100 GHz approximately. Also, we can see in terms of mobile lines, the 2005 to 2019, we have many million of people. They have more reach the mobile lines. So this way, digital mobile in Spain, this is how it works. It has more 27 million according to IN 2020, which of the increase 9% compared to 2005. Also, number of mobile device line rose 25% in the same 5-year period. Currently standing to relationship to 25 million mobile devices, according to the CNMC 2020, the technological development of the mobile network for base generation described below. Here we can see some literal review and how it works, how evolves the technology from 1G to 5G. We see the materials. The investigation of technology of the viability of deployment 5G networks established and described. According to Segarra 2012, they clarified the discrete research. This called theoretical research science is disseminated to solution problems and or improvement trends or opinions in a sort of medium-term procedure focused on techniques of increasing the most effective and productive capacities. In the development of the research, the described design was determined. It allows the researchers to be oriented to describe the context from the research study, according to the experience in this design base of the theories that is generated through the collection analysis of data according to the theory of Hernandez. According to the research that follows, variables are identified. Independent deployment 5G network, dependent characteristic radio frequency of spectral small cells. Results. The results study of technology 5G network managed to identify tangible and intangible results, so it detailed below. The presence of 5G will benefit the user population, which is great speed spectrum, reaches the speed to 10 to 20 to 250 times more compared to the currency communication. In a relationship, in relation to the speed of 20 gigabytes, the technology will support downloads of virtual environment application. It is necessary to specify not only coverage specification but also allows to eloquency extend expansion cover. Likewise, broadband, the wireless network support the data link within the area approximately 20,000 devices. It also link in remote areas. Video conferencing application benefits the entire population, including the indigenous population. 5G network will not only apply to the practical case used to users. Generation of jobs in a world economy. Presence of 5G technology will create millions of jobs distributed in the transport, health, education, automobile industries, energy, among others. The positive impact will come from smart cities to small cities. Regarding education, 5G technology will protagonize the protecting of many jobs. Obviously, the training will carry out the virtual online courses. Also, people from inaccessible locations will have access to technological opportunities in the same link of children will enjoy receiving information about the homework gap as well as having access to a broadband at home. It is necessary to determine the relevant launch in relevation in individualized education with technology development of machine learning, big data, and it will admit experience finding rich, precise, and model exhaustive application which demand broadband, greater data location, and progressing, teaching, personifying, and accommodation of the model of in addition. The relationship of energy 5G technology will contribute to clean energies through smart grids to make up renewable media and wind and solar increase dependent on the weather station. as well as possible as having the smart lighting of thousands of streets. In the same way, a specific sensor to prevent effects of climate change, monitoring of key places for industrialization. The arrival of Internet with 5G has not only evolved its entire the form of model communication, but also have instituted many smart business models, such as data access control, multiple online services, smart cities, infrastructure systemization, smart agronomies, autonomous pipelines, smart health services, smart logics, and system and others. The deployment of 5G technology will help traffic lights to manage the intersection and to influence more efficiently signs. It allows to discover the vehicles approaching to the place, and likewise, it will have greater control to the axis of speed. It will have better supports for terminal design, as well autonomous car will communicate with each other and drive themselves. Within 5G technology, health professional will have access to use virtual reality, which allow attentive to patients who are involved external place, which uh, with the support of artificial intelligence plus monitoring access to a large block of data, which will help the professional to identify various diseases to find treatment with greater precision and speed. With the availability of 5G, we'll obtain most efficient increase yield monitoring. Here we can see that a comparison between 5G network and 5G network. Speed, latency, quantity of dispositive, IoT, and rural connectivity. In this way, the best characteristic to observe will warranty the deployment of 5G network, which according to the standard speed, the communication speed of 5G network is 10 gigabytes per second, which is predicted to have a greater speed 10 times more the connection than mobile device currency. Despite the noticeable increase in speed, the traditional most lucrative characteristic of 5G network is the lowest latency, which includes the response time of communication of the network and the time sending in and receiving data. The technology of 5G network ensures a maximum latency of 5 milliseconds, achievement peaks of 1 millisecond, which means they resolve less time 4 to 20 times than 4G network technology today. The advantage results will provide not only the link between people, also communicate in real time, which environment also links between machines M2M with a wide density of devices coupled with 5G network technology that produces the 100 going more than 10,000 kilometers to 1 million K2 kilometers square, enormous numbers of coupled machines and devices. Linked autonomous vehicles, mass communication, IoT, Internet of Things, smart couple, computerized industries, telemedicine with remote surgeries. Here we can see the low rate benefit of IoT, that low latency and autonomous cars. It can activate a braking of 0.75 seconds that indicates if you travel 100 kilometers per hour, you will stop at 20 meters. As long as a driver acts ultra low latency, 5G technology will respond to 1 to 5 milliseconds latency. The same way a car will respond in a 15 running distance 15 centimeters in relationship to react time. This communication behavior 5G network create an impact to human society, from systematization to automation of smart industries, autonomous vehicles, remote telemedicine incubations, and more. The relationship is more sought than from study research. The characteristic capabilities and more sought of the 5G network technology designed and built are determined, which allow to identify one of the most appropriate small south structure, and obviously it's possible to identify that between the mean dipole waveline as mean asymmetric dipole waveline. bandwidth is limited despite having optimized techniques in the structure. With a mean asymmetric dipole waveline, it was to experience in bandwidth that allows increasing weight of lines, and its consequence, the surface insert has increased. Relatively, both dipoles of small self spherical degrees are reduced. Here we see more results. We will go straight to the discussion. The best characteristic with warranty deployment of 5G networks is observed, which according to the standard speed the communication system 5G network is 10 gigabytes. Is predicted is more than 10 times more links connected to the device in today. We have other characteristics like mass communication with IoT, smart computer and computer industries, and telemedicine. Also, we see great benefit with low latency autonomous car, and in relationship with the radioelectric spectrum, the researcher was oriented with radio frequency spectra to determine the frequency band required 5G network, such as 700 MHz, 300, 3600 MHz, and 26 GHz. Small cells will send signals to the closest mobile determinate that shows perceive clearly less interference coming from antennas with larger structure and emits signal with greater power coverage, which is obviously located much further away from the location. And it should be noted that the terminal will be linked to the area that achieve the higher signal, there is less interference and user experience, a faster download with small cells. Also, the user is closer to the antennas will manage to transfer less power, subsequently reducing the interference and or global noise. When they reach the antenna, the noise interference will experience the antenna too high to determine to make itself the transfer to the high power. It's estimated that theoretical return loss obtained the study electromagnetic plaster and 5G technology to photo cells show that S11 is less than 10 dB, a bandwidth less than 50% interfere with small cells. The return loss shown reveals that it has wideband 90.94 up 35.86 GHz and interference range on 90.84 GHz to 55.7 GHz. Likewise, the antenna return loss is both radio microcell exhibits with a band of 132% to 70.78 GHz in a frequency range from 1022 GHz to 90 GHz. It should be noted the procedure of simulation of loss of return radio microcells antenna. It was developed 90 GHz. It is possible to appreciate levels of return level less than a return higher than 90 GHz per issue and excess lower than 10 dB. The loss due to the return of the path key that they teach process a broadband 76.31 and or 29 GHz in frequency interval of 23.5. The antennas for the 5G technology of radial microcell representation a conserved wideband of 81.17 or 28.87 GHz with a frequency interval of 21.13 GHz to 50 GHz. And this reduces the noise. Development of 5G technology would benefit human society in different areas. We see this here before. We finally have the reference. Okay. Thank you so much for attending this meeting.